Welcome to the project demonstration of virtual doctor robots with video surveillance and health parameters monitoring with obstacle detection. So in this project mainly we have the features like we can get the visuals from the ESP32 camera to the mobile phone through the IoT, and from the mobile phone only we can control this robot movement forward, backward, left, right, headlight on and off. And the next feature is while we are controlling the robot, if any obstacle detects, then automatically it stops its movement. Like for example, while moving that in corridor, so if any person is coming in front or in midway, then automatically the movement will be stops based on the obstacle detection if the obstacle is less than 1.5 feet. And the next is we can get the parameters like we are using the max 30100 sensor and temperature sensor to get the patient health parameters. So when he or she places finger inside the sensor, so we are going to capture the health parameters that will be displayed on locally on this LCD screen, and same thing it will be sent to the doctor mobile phone. So on this one we can see heart rate, SpO2, temperature and the distance of the objects. Okay, so that is continuously monitoring. So vice versa, once we are going to control the robot movement from the mobile phone, and also the data will be sent from the robot part to the mobile phone section. So for this achieving the features, we are making use of ESP32 camera, SR0 for ultrasonic sensor for obstacle detection, and max 30102 as well as temperature sensor for health parameters. So max 30102 will provide us the heart rate and SpO2. Temperature sensor will provide us the temperature of the person, and the same will be displayed on this 16:2 LCD screen. And these sensors and the LCD interface to the Arduino board here, so which will taking care of input from the ESP32 camera. So means the commands to control this robot movements will be received by this ESP32 camera to the Arduino Nano board, and the sensors and output modules display along with these two DC motors interfaced to this Nano board through this L298 motor driver. So which was interfaced to this GPIO pins of our Nano board, and the whole system getting power supply from this 12 volt 2 amp battery pack which is rechargeable. So before demonstration actually we need to charge a battery under full charge. So for that we are providing this charging circuits. Just on the power supply to this transformer, and the next connect this 2 pin at this B slots. Okay, so they have done the B slots. Now on that we can see the light indication battery is charging. So it will take around 5 to 6 hours to be fully charged. Till the duration we should keep the battery under charging, and after that automatically this charging circuit will block the current flow to the battery if it is fully charged. So that's why the first step is like keep the battery under full charge, and the next the output of this 12 volts DC is input to the motors through this L298 motor driver, and the operating voltage of our microcontrollers in Nano board along with camera and the sensors modules display is 5 volt. So to convert the 12 volts DC to 5 volts of DC, we are making use of this LM2596 voltage regulator. So this one is the LM2596 voltage regulator, L298 motor driver. And the next, this one is the breadboard to distribute the 5 volts power supply throughout the modules. So once LM2596 provides the 5 volts, so that will be distributed throughout the input output modules. So the next step is before on the kits we need to enable the hotspot, because to communication between the mobile phone and the kit it should be done through a network. So that is we need to enable the hotspot in your mobile phone. That is project 7272 without any space, without any capital letter. Password 129.123456789, and AB band should be 2.4 gigahertz. So after enabling the hotspot, now the next step is we need to install the network analyzer application. So this is the application we need to install. Icon of the application available in the Play Store. So the IP this network analyzer application purpose is to get the IP address of our camera. So after all this setting was done, now we can on the power supply to the kit. This is the on off switch, right? Okay, and we are using the DC motors of 12 volts 10 rpm DC motors, right? So after some time you can see one device will be connected in your mobile phone, right? So after this confirmation, go to network analyzer application, options, LAN scan. So they will get the two IP address. One is our mobile phone, another is ESP, that is ESP32 camera. Just click on that and open in the Google Chrome. So there we get the visuals along with these 4 parameters. So heart rate, SpO2 as of 00. That's why there is no input to that, and the same displayed on this LCD screen. And the temperature Thus we'll getting the room temperature surrounding of that one, and obstacle detection is around 105 centimeters. You can see that if it is near to this, then you can see the 11 centimeters. We're increasing that, the obstacle also will detecting and increasing. So just when we press on that, let's keep on moving forward. So any obstacle detects, automatically stops. So back controlling, forward, left, right, stop. So then in order to get the health parameters, I will just need to place the finger inside this sensor. So let us wait till the sensor got stabilized the parameters, and then the starting of heart rate and will be stabilized slowly. The same data is continuously sending to the mobile phone. Right. So once the heart rate got stabilized, then only we will get the valid SpO2 data. Right. And let us see on the floor. So while movement, if any obstacle presents in front of that, so you can see the distance also over here. Same headlight feature. Right. Thank you.